Hello everybody, welcome to another video lesson. We are now going to take a look at our binomial theorem, and we're going to expand binomial expressions, and we're going to take a look at how this kind of plays into our series and sequences. So let's hop into our binomial theorem. Remembering the binomial theorem is just an expression involving the sum of two unlike terms, right? Now, with that, we saw last video that there was a lot of patterns going on when we were expanding these binomials. And every time we see patterns like that, we can start to think, okay, this maybe is a sequence or a series. And since we're adding a bunch of terms together, we're going to think of these binomials actually, or these binomial expansions, as series. So for instance, if I have a plus b raised to the n power, each of my terms, I'm going to have the coefficient that's going to be found out by taking n choose 0. N choose 0. Okay, we're going to start off with 0 always what we're choosing, and then that value is going to go up 1 each term. Okay, so my first term, my r value is what we're going to call this, is going to be 0. So for each of my coefficients, n choose r, again, that's going to be n factorial over n minus r factorial times r factorial. And then for each term, my r value is going to increase by 1. So r starts off as 0. For the second term, then r increases to 1, and so on until you reach the coefficient or the value that r equals n. Okay, so let's take a look at this example. A plus b squared, real simple example. So my first term, I'm going to have the coefficient 2 choose 0. And then I'm going to have a raised to the 2 minus 0, b raised to the 0. So again, this 2 minus 0 comes from 2 minus 0, and then this term is always being raised to the r power, always. Okay, and then my first term is always being raised to the n minus r power. Again, always. So n minus r and r are what these are being raised to. So my second term then, my n doesn't change, that's still 2, but now I have 2 choose 1. So my r value has gone up by 1. So now again, I've got n minus r, so 2 minus 1, and then b is raised to the r power, which in this case is 1. And then moving on to my next term, I'll have 2 choose 2, and you can just keep on going and going and going. So now expanding each one of these out, I'm not going to go over what these factorials mean because we know that from previous classes, but this is what it's really coming down to and how we can expand it out and then simplify it back down to be a coefficient. Okay, so once I simplify this 2 factorial over 2 minus 0 factorial times 0 factorial, that's going to be 1, and then 2 factorial over 2 minus 1 factorial times 1 factorial, that's going to be 2. So again, these factorials are how we are getting these coefficients right here in my expanded binomial. Okay, so let's hop into some examples here. Find the coefficient of the third term in the expansion of a plus b raised to the 13th power. Now, you could go ahead and write out Pascal's triangle for this whole thing, but doing 13 rows or really 14 rows of that is going to be quite a bit of work. So instead, we just got to find two things. We got to find out what n is and what r is. Now, I know that n is always just whatever this power is, right? So n is 13. That's how we find that. N is 13. Now, my r value we get by looking at what term we're looking at. Okay, so we're looking for the third term. And remember, r is always one less than the term number that you're looking for. So since I'm looking for the third term, that's just going to be r is going to be 3 minus 1 or 2. Right? And then to take a look at the whole term that's going to be, remember, n choose r times a to the n minus r times b to the r. So that's true for every single term. Okay, so my n again is 13, so I've got 13 choose 2, a to the 13 minus 2, b squared. So now we can expand out what this 13 choose 2 is, and a lot of times your calculator can do that as well, but we're going to go ahead and do it real quick here. So I've got 13 factorial over 13 minus 2 factorial times 2 factorial. 13 minus 2 simplifies to 11, and then b squared. Okay, so simplifying this will be 11 factorial times 2 factorial in my denominator here. I'm going to rewrite 13 factorial as 13 times 12 times 11 factorial, and I'm going to do that because it'll cancel out with this other 11 factorial, and then 12 over 2 is going to simplify to 6. So now I just really have 13 times 6 times a to the 11th b squared, and 13 times 6 is going to be 78, but it's just asking us for the coefficient here, just asking us for that coefficient, so our final answer will be 78. Okay, second example, find the coefficient of the x cubed y to the fifth term in the expansion of 2x minus 3y all raised to the 8. Now remember, we need to find n and we need to find r. N we get from whatever this index is, and then r we get by taking a look at this 5 here. Why is that? Well, remember, our second term is always being raised to the r power. So since r here, or since this term is being raised to the fifth power, I know that my r value is actually 5. Okay, so again, writing out n choose r, a to the n minus r, b to the r. Here I've got 8 choose c, a to the 8 minus 5, b to the fifth. Okay, just plugging in my n's and my r's here. Now I know that a is actually 2x. Okay, so this whole thing here is a, and then I'm going to think of b as negative 3y. All right, so I'll have 8 factorial over 8 minus 5 factorial times 5 factorial times 2x to the third power, negative 3y to the fifth power. Okay, so now you can see here that y is going to be raised to the fifth power, which is what we were looking for up here. So then starting to simplify my terms here, simplifying each of my terms to 8x cubed and negative 243y to the fifth, and then starting to simplify what this 8 choose 5 really means. I'm going to rewrite 8 factorial as 8 times 7 times 6 times 5 factorial. I'm going to do that because it's going to cancel out with my other 5 factorial in my denominator. And then 3 times 2 is going to cancel with my 6. So trying to find the coefficient, again, I'm just going to have 8 times 7, I get that from here, times 8, which I get from here, times negative 243, which I get from right there, from that y term. Okay, and I'm just multiplying all these together, and when I do that, I'll get negative 108,864. Okay, next example, we're going to expand this whole thing using the binomial theorem. So we're doing a full binomial expansion on this one, and I'm just going to raise 5m plus 4 all raised to the third power. So for each of these, remember, n that choose r, 5m is going to be like my a term, that's my first term, raised to the n minus r power, and then my b term, my second term, is just 4. Okay, so we're raising that to the r power each time. Again, my n is 3, get that from my original binomial. And then my r is going to change. Remember, it starts at 0, so I'll have 3 choose 0, 5m to the 3 minus 0, 4 to the 0, plus 3 choose 1, and then 5m raised to the 3 minus 1, 4 to the 1, plus 3 choose 2, 5m to the 3 minus 2, 4 squared, plus 3 choose 3, 5m to the 3 minus 3, times 4 to the third. Now remember, once these two terms are equal to each other, we can stop. Once I have n choose r and r is equal to n, I can stop, and I'm done. Okay, so going ahead and expanding out these 3 choose 0, 1s, and 2s, and 3s, and kind of cleaning up what my coefficients, or what my terms are actually going to start looking like, this 5m and this 4. Okay, here is all of our expanded 3 choose whatevers. Okay, so for this first term, I'll have 1 times 5m to the third. My second term is going to simplify to 3 times 5m squared times 4. Third term will be 3 times 5m times 4 squared. Let's see, and then my last term will be 1 times 4 to the third power. Now, take a look at what we see here. I've got 1, 3, 3, and 1 here for these coefficients. Now, if you were to draw out your Pascal's triangle, remember that's going to look like this, right? Okay, and since n is 3, I would want to use this term right here because my second term is going to be 3. And that's actually what I have, 1, 3, 3, and 1. So you can really easily check these if you know what your Pascal's triangle looks like, because this triangle is built off of the math that we're doing. So you can know if you're doing this correctly if it matches up with the triangle. Okay, and then just simplifying each one of my terms, going through and kind of distributing these powers to each one of the terms within them, and we'll get a final binomial expansion that looks like this. Okay, last one here. We are going to represent our expansion of 3a plus 12b all raised to the 30th power using sigma notation. Sigma notation here, okay? And we know that we have patterns here, which is why we want to think of this as series and sigma notation, right? This is kind of how we're tying this all together. So let's think about what our n value is. And we know that we get that from right here, right? So that's going to be 30. Now let's think about what R is. Well, I don't really know what R is because R changes with each term, right? R starts at 0, and then what happens? It starts at 0 for the first term, and then for the second term it goes up to 1, and the third term it goes up to 2, and so on, right? So we add 1 for each term for R, and then we stop when n is equal to R, right? So when R equals n, we're done. So just with that information right there, we can tell that R is going to be our iteration counter, which is usually that's like our dummy variable, right? That's what we've been calling it. So I can start to put this into sigma notation already just by this information. So my R is going to start at 0 every time, and then it's going to end at whatever n is, which in this case is 30. So I'll have, I get the sigma part of this sigma notation done right off the bat just by figuring out what n is and understanding what's actually happening with R. Now my n choose R part, that's going to help us with our coefficient, right? Now, a lot of the times we can also denote this n choose R as n over R all in parentheses. Okay, so that's how we're going to do it when we're writing in sigma notation. So make sure you're writing it like this. So I'll have n, which in this case is 30, over R all in parentheses. Okay, and then for the actual terms, right, the a's and b's, which in this case is 3 and 12b, we have a raised to the n minus r, b raised to the r power. So we're just going to keep that in there because that is going to be how we are developing the terms that we're adding together within the sigma notation. So instead of a, though, I've got 3a raised to the 30 minus r, and then 12b raised to the r. So if you were to really think about this and take a look at how you would expand out this sigma notation, it's going to be the exact same thing as the expanding out this more algebraically, right, instead of with a sigma notation. Okay, so that is it for this video, you guys. Good luck with your practice.